and more pollutants are entering the environment through agriculture, industry or urban wastewater, with negative impacts on ground and surface waters. For example, the excess use of nutrients in agriculture is one of the main reasons for the algal blooms we see in our surface waters. Other substances threaten water quality, for instance, when abstracting drinking water from surface water reservoirs. The Rappbode Dam in the Harz region of Germany is one of the country's largest drinking water reservoirs. Scientists from the Helmholtz Center for Environmental Research are taking water samples. The researchers are involved in the integrated project Catchment Dynamics. At first glance, the water sample taken by the scientists at the Rappbode Dam looks clear, but if you look more closely, it has a distinct brownish color. The distinct color is caused by so-called humic substances, dissolved natural organic carbon compounds, and they can pose a serious problem for drinking water supply. The whole situation is aggravated by the fact that in Central Europe, Northern Europe, but also North America and other parts of the world, we have been finding increasing concentrations of humic substances in our surface waters for a number of years. This means we're probably going to face an even greater problem in the future, along with associated consequences for water supply. The water treatment plant at Wienrode, where the water from the dam is treated to make it safe for drinking. Extensive cleaning processes are required. The removal of humic substances is particularly time-consuming, but a key process in drinking water treatment. If the water has to be chlorinated, for example, chlorine is added for disinfection, reactions between the chlorine and certain humic substances may result in the formation of toxic byproducts, which are potentially dangerous to human health. Therefore, the humic substances have to be removed in the water treatment plant, which of course incurs costs. But where do these substances come from? The answer lies in the upper reaches of the Rappbode. As water passes through vegetation, the litter layer and soils, it takes up dissolved organic matter. These humic substances, which are natural products of biomass decomposition, are primarily mobilized and exported from the wet riparian zones along the Rappbode during intense rain events. We still have a relatively poor understanding of the precise processes and dynamics involved in the transport of humic substances. As scientists, we want to help improve the understanding of these processes. The scientists involved in the project are therefore working in interdisciplinary teams. Hydrologists, biogeochemists, and social scientists are developing predictive models for the transport of humic substances and other solutes and the associated changes in concentration. The results of our models allow us to provide the dam operators with valuable insights into how to operate their dam in the future, and we can also provide information to the water suppliers about how they need to prepare for concentration levels in the future. In many places, also critical concentrations of nitrate in groundwater can be observed. This is especially common in agricultural areas where liquid manure is used as fertilizer. Besides nitrate, there's also a whole range of other substances which are also released into our environment. For example, so-called new emerging contaminants, new chemical compounds which did not exist in the past or which could not have been measured until more recently due to their very low concentrations. Our work is also focusing on the transport and environmental fate of these substances and how they get into our drinking water. The integrated project Catchment Dynamics is one of 11 interdisciplinary research projects now being carried out by the Helmholtz Center for Environmental Research, UFZ. The knowledge it generates will allow an important step forward to better understand our environment and to resolve the conflicts between humans and nature. Thanks to the wide range of expertise of the scientists involved in the integrated project Catchment Dynamics, we are all well prepared to solve these complex problems. Through our work, we can make a valuable contribution to society by helping to achieve a good ecological and chemical status of our water bodies and to ensure a reliable and safe supply of drinking water for years to come.